You know what's amazing about a Cisco iOS router is that it'll do routing till the cows come home, meaning it'll take an incoming packet, look at that destination IP address, look at its routing table, might find a match, and then route it on its way. And it does that millions and millions of times a day. However, we may not always want the router to forward all traffic. So in this video, we're going to take a look at the concepts of packet filtering using a method called an access control list. And as we talk about filtering packets and controlling traffic at the router, let's consider a guard shack like this one right here. Now, this guard shack appears to be at the entrance and exit of this gated community. And what are the benefits of having a manned or womaned guard shack at that facility? I mean, there are some negatives. It's going to cost money. It's going to take extra time to go in and out. So why? Why do we even have a guard shack, and what benefit does it provide? And when we consider that, some of the benefits might be, well, we can control access. We can have people, when they show up at the gate, be cleared and be asked by the guard, okay, who are you here to see? What's your name? Who are you? And then the guard can make a decision on whether that person can come in. Or if somebody's trying to leave the community, we could set up the security to check individuals on the way out as well. So having control of the traffic, or people in this case, going in and out is one of the big benefits of having a manned or womaned security guard at the entrance or exit of that community. And let's take a moment together to consider how this could work. So we could have the guard or guards in this facility here in this building, and then we could give them a list. Now that list could be updated a variety of ways, but this list could identify who is allowed in and or out. So if you and I were visiting somebody in this complex and they were expecting us, they could put us on the list. So I'm going to put on this list me and you. So we're both on the list, and the action is for them to allow us, meaning please let us in. So we show up at the gate. The guard says, hold on a moment, looks at the list, starts going down the list, finds me and you, says, yep, you're allowed, opens the gate, lets us through. Now it's quite possible that that guard is going to have more than just me and you on the list. There may be John and Alice and Bob and Lois, and maybe there's a troublemaker among them. So maybe Alice is on the list, but she's been identified as a malicious individual, and the guard has been told explicitly, hey, you know what, if you see Alice, deny her entrance, meaning don't let her in. And maybe John we're allowing, and Bob we're allowing, and Lois we're allowing. So let's answer this question together. If somebody shows up at the gate and they want to get in, and the guard takes a look at this list, and he goes, well, it's not me and you, it's not John, it's not Alice, it's not Bob, it's not Lois. What do you think the guard should do by default if someone shows up and they're not on the list? And hopefully we've trained the guard that the default behavior should be deny. Say, sorry, you're not on the list, there's no match, I'm not going to allow you to get in. And this scenario that we've just gone through together is just like how a Cisco router works when we apply an access list for filtering on its interface. Let's put the pieces together. So imagine this is our Cisco router. And this right here is one of its interfaces. Let me go ahead and choose a different color there. And what we can do is we can create this list of traffic that should be permitted or denied. We can hand that to the router, and we can say, regarding this interface, we want you to only allow certain types of traffic or deny certain types of traffic. And just like the security guard, the router, when traffic shows up, it'll compare it against the list, starting at the top, work its way down, look at the list, and then it will follow the instructions, either permitting or denying, regarding each and every packet that shows up at that interface that would like to be processed or forwarded by that router. And the process for using an access control list on a router interface is 3 basic steps. Number 1, we need to have a plan. And that means just logically, what do we want to filter? What do we want to permit? What do we want to deny? And think it out first as far as what we want to do. Secondly, we'd make a list, and that list would include a list of certain types of packets that we want to permit, other types of packets we want to deny. And then third, we'd go ahead and apply that list to an interface on the router. So if we apply the access control list here on this gig 00 interface, we'd tell the router, okay, we're going to apply this access list inbound on this interface. And what that means to the router is that, okay, the guard is now in the guard shack. Any new packets that show up on this interface, before the router just processes them nilly-willy, it's going to take a look at the packet. The router's then going to take the list. Let's imagine the list has 4 lines in it. And this could be lines 10, 20, 30, and 40. It's simply an ordered list. And the router looks at entry number 1, says, is this packet match this entry in the access control list? If the answer is no, the router says, oh, bummer, I'll check the second entry. So it checks this line. Is it a match? No. Checks the next line. And if there's a match on this third entry, let's imagine that the access control list says, if traffic is coming from 10.1.0.40, go ahead and deny that traffic. That would match on that line. The router would say, oh, this is a match. My action is deny. And it would simply drop that traffic right there. And once that match is found, the router acts on it and goes on to the next packet. So let's imagine next that there's this host .50 that sends a packet. And let's imagine this second entry in the access control list says, if traffic matches the source IP address of 10.1.0.50, go ahead and permit it. So with that new packet going into this interface, the router goes down the list in order. The first entry doesn't match, the second entry does, and as a result, that traffic is permitted, and the host at .50's traffic is then routed through the network. And if we have another host at .60, and the router gets a packet from .60, and it goes through the list, and doesn't find any matches in a Cisco access control list once it's applied to an interface, if there is not a match, it is denied. The traffic is. So there's what's called an implicit, it's implied, deny action at the end of an access control list if there wasn't a match somewhere in that access control list. So what we've done is we've taken a look at how we can use an access control list for the benefit of controlling traffic or filtering traffic by designing, thinking about what we want to permit or deny, creating a list that identifies that traffic with permit or deny statements regarding what we want to permit or deny, and then applying it to an interface on a router, which basically tells the router, okay, great, new packets that show up, now you have to process this list and only permit traffic that is explicitly permitted in the access control list. So that's the basic concept of an access control list used for packet filtering, and in the next video, we'll take a look at the two categories or families of access control lists. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.